We're excited to present PV-Pix, the result of a collaboration between material science, design, and engineering researchers, as well as slum community co-designers. PV-Pix are a novel computer-mediated form of inter-family expression using interactive and self-sustaining photovoltaic material. Using PV-Pix, a person in one household can create a pictographic message, such as a reminder to bring an umbrella, which is subsequently displayed in another, connected household. PV-Pix are inspired by advances in material science that have created exciting new computational materials. Materials that can harvest sufficient energy from the environment to carry out functions such as sensing, actuating, as well as storing and communicating information. We wanted to explore the forms and functions such materials might take on outside of the research centers in which they are typically developed. In our case, this was with emergent users in Dharavi, one of Asia's largest slums located in Mumbai, India. Dharavi has around 1 million residents who are culturally and linguistically diverse. They have varying levels of textual and media literacy. This is why they're sometimes referred to as emergent users. That is, people who are just getting their hands on advanced digital technologies, such as the mobile phone, but aren't necessarily able to access all functions.
Before the pandemic, we conducted co-design workshops with community members. Participants recognized the value of self-powered devices because there are only few electrical outlets in a typical Dharavi home. They also valued connecting friends and family. To further investigate how computational materials can be embedded into fabric and surfaces of a Dharavi home, we organized a follow-up diary study. Because of the pandemic, this study was conducted remotely using WhatsApp. Over the course of a week, study participants showed how they arranged and rearranged their home, depending on people and activities over the course of a week. Together with residents, we identified windows and room dividing curtains as promising places. To give participants a sense of interactive possibilities that could be driven with small amounts of energy harvested from these windows and curtains, we created a low-fidelity prototype that we deployed with participants in Dharavi over 4 weeks. Here's what they looked like. Encouraged by the creative and meaningful messages that participant families shared with each other during the study, we took first steps to engineer technical prototypes. To implement these, we choose dye-sensitized solar cells or DSSCs because of their low light performance, aesthetics, and low manufacturing costs. Compared to other photovoltaic materials, DSSCs can generate enough energy from indirect light to drive low power actuators and communication radios. DSSCs are dye sensitized and semi-transparent. We utilize these properties to give PV-Pix a pleasing aesthetic dimension. And finally, DSSCs are comparatively low cost and easy to manufacture, opening up exciting possibilities of local manufacture and customization. Moving forward, we provide a toolkit to accompany this paper in order that other researchers can join us on this research journey. And looking back, we would like to thank the co-designers, participants, facilitators, and funding agencies who enabled this research.